Good morning, I'm Dean Mikkelsen, the editor of Oil and Gas Middle East, and we are in Saudi Arabia at the IPTC conference. And today we're talking with Tom, who's a product manager here at STRYDE. And STRYDE has developed some innovative technology that relates to seismic acquisition and processing. So Tom, as a product manager, can you tell us more about what this little one is and compare it to the older days?
Sure. So what we have here is essentially a completely self-contained and autonomous seismic recording node. It's been designed specifically for land seismic applications, and we focused really hard on the essential elements that you need to record high quality, high density seismic data.
Can you expand on those elements that
Sure.
are required?
Yeah. So before I do that, we'll talk about high density seismic. So a lot of industries need seismic data. Anything that is extracting or injecting material into the subsurface can benefit from seismic data. But for too long, it's been way too expensive. And that really comes down to the recording equipment used to acquire those surveys. You had to transport extremely large quantities of very heavy, difficult to use and unreliable cables to acquire the data. Now you have this very high-tech, very lightweight node. It's very easy to transport it to the field. And once you're there, it's extremely easy to use, and you don't require a whole army of people to keep the system running. So the specific things we put in the node to make it work so effectively is a 1C piezoelectric sensor, which is actually what's detecting the vibrations and the reverberations from underground, from the energy source you put in, which is typically...
And we can use our still traditional energy sources, explosives, vibrators.
Yes, exactly. So the node doesn't really care what energy source is.
Just as long as the wave comes.
Exactly. It's just there and listening, and then when you take the data off the node at the end of the project, you can then just slice out all of the traces you need from the times where you're actually actively acquiring the shots, and then that's what then goes to the processing center. So in addition to the sensor, we have the battery, which gives it a minimum of 28 days recording time in the field. You have all of the electronics that digitize the signal from the sensor and write it onto the memory card. You have a clock and a GNSS chip, and that is really critical for ensuring that the final data is time synchronized across all of your nodes. And then you have electronics for charging and downloading the data. And so if you look carefully...
the size of this, so you could have a very dense grid, small area.
Exactly.
Okay.
So the nodes are so compact, you can transport tens of thousands of them very easily. They're very easy to air freight if you have a project in a remote location, or you need to stage some nodes in a distant part of your survey area. The other thing that you'll notice is that if you look around, there's no exposed external connectors. So that, one of the clever things about the node, and again, one of the things that makes it very efficient in the seismic camp, is you don't need to disassemble this to charge it and download the data. You can load 90 nodes at a time into our charging and harvesting unit, and that will simultaneously...
So essentially you plug it in here and it will charge.
It's actually the top.
The top.
Yeah, so the top is transparent because the data is transferred optically, so it needs to have a transparent path for the infrared light to move along. And it is charged inductively, so if you have an electric toothbrush, kind of in the same way, and that can happen simultaneously. But that's great because it means that you can handle a large amount of nodes with a small crew in camp, because you're carrying blocks of 90 around, loading those in, and then everything happens simultaneously. Nothing to disassemble. There's no need to maintain this when you're in the field. So it's all very simple and slick operations in the field.
And it's been working extremely well here in the Middle East?
Yeah, we've done several projects now in the Middle East, ranging from kind of the full spectrum of sizes, from geotechnical type applications all the way through to mega crew surveys. Our largest crew in the Middle East has been operating for over two years now, operating 160,000 STRYDE nodes, producing very high quality.
160,000?
Yeah, 160,000. So for such large channel counts, we can deploy a shipping container that's fitted out with all of the kind of peripherals that you need to handle the nodes in camp, charging, data download, and data management, along with software that is custom made for our
you have
STRYDE
your own
system.
software that does it, but it can also feed into traditional other software packages as well.
Exactly. So we have, and we're investing in always improving our software specifically for handling the data volumes that come off our nodes. So the whole system is very, very automated and optimized to get the data off the node and onto your hard drives, ready to be shipped to the processing center.
And with a denser grid, you're getting much more data than we have traditionally in the past.
Yes, there is more data, but that's not an issue because we're very focused on optimizing the automated QC of the data and also providing very good QC tools for interactive QC as well. So we've got the tools for the job. Handling large amounts of data is no challenge for the STRYDE system because everyone looks at the node and goes, wow, this thing is 150 grams and 13 centimeters tall. But you have to think about the whole value chain of acquiring a seismic survey, the number of people you need in the field, how long it takes to actually plant the sensor in the ground, how long it takes to download the data. And so we've really solved the whole chain.
And reduced the number of people out in the field.
Yes.
So it's also a safety
issue
as well.
There's kind of a capex benefit of using STRYDE because we aim to make these in high volume and at low cost. So this is an inexpensive seismic node, but also the operating cost is where you get as much benefit because you need fewer people to manage the nodes in camp, and you need a lot fewer people on the line to actually deploy the nodes. And even with a smaller crew, you get higher productivity than you get with conventional systems. So it's kind of winning on both sides.
Perfect. This is really interesting technology, and I want to thank you.
Yeah, thank you very much, Dean. Lovely to meet you.
Cheers.